Hello students, till now we've been discussing about magnets. So now what if I say that you can have or rather create a magnet of your own? Why always rush to the market to buy a pair of it? How about creating one of our very own? Sounds interesting, right? Okay, so today we will study as to how we can create our very own magnet. So we've already studied in our previous modules that a magnet, it attracts materials which are made up of iron, nickel, or maybe even cobalt. And what do we call such materials? Yes, they are called as magnetic substances. Like here, when a magnet is brought near to the iron pins, then they get attracted towards it. Yes, they are called as magnetic substances. Like here, I have a bar magnet, and when this bar magnet, it is brought near to these iron pins, so they get attracted towards it. And these pins, they are more crowded at the poles of the magnet. You see, they are more crowded near the poles of the magnet. Now let us do an activity by using oil pins and paper clips. So again, I'll make use of this bar magnet, and when a paper clip, it is brought near to it, it sticks to the bar magnet. You see here, the paper clip, it sticks to the bar magnet. No confusion till now, right? Because you all know that this paper clip is a magnetic substance, and so it gets attracted towards the magnet. Now, when I bring an oil pin near to the end of this paper clip, then let's see what happens. Well, it also sticks to the paper clip now. Interesting, right? But have you observed that this oil pin, it is sticking to the paper clip and not to the bar magnet? So can we call this piece of metal, the paper clip, to be a magnet? Well, no, right? You won't call this as a magnet, it's just a metal piece. So how does this oil pin, it sticks to the paper clip? Well, the paper clip is no magnet, and nor is the oil pin. Then how is it sticking to it? So here, I want you to think that what could be the logical reason behind this. Okay, let us try something more interesting now. So what I'll do is, now I'll bring another piece of oil pin close to this setup. And you see, even this sticks as well now. Though the attractive property of the magnet, it is progressively going to get weaker as we go even more down. But as you see, the second oil pin, it also sticks to the first oil pin, which is sticking to the paper clip. But you see that even though these paper clips and oil pins, they are made up of mild steel and they are not actually a magnet, they have now started to behave like one. Now what happens when I remove this permanent magnet bar away from this? Okay, so I still see that it is quite surprising what I observe now. The oil pins, they are still sticking to the paper clip. And now if you keep holding the paper clip for some time, you will find that these oil pins, they'll fall down gradually after some time. Do you know why does this happen? Now that's because the paper clip here, it acquired weak and temporary magnetism. And so the oil pins, they stuck to it when we brought them closer to the paper clip. However, when the paper clip, it got demagnetized after some time, then all the oil pins, they started falling down gradually. Now I have a small homework for you all, and that is to think what made these metals or alloys to behave as magnets. And we'll be discussing the answer to this in the upcoming modules. For now, let us come back to our main topic of discussion for today, which is to understand that how can we make our own magnets. Now we all have studied or at least heard or maybe even used the magnetic compass. And what's a magnetic compass? So it's the instrument that helps us in finding the directions, right? Okay, but can you imagine that you can also very easily make such kind of device by yourself? Surprised? Well, you shouldn't be, because here I'm going to teach you a very easy method to make your own magnetic compass. So all set to make your own magnetic compass? Okay, there we go. So here is a cork with a needle which is placed on it, and this arrangement of cork and needle, it is placed in a bowl of water. So as you can see here that the cork needle assembly, it starts to float. But you need to make sure that the needle, it does not touch the water. Now let us check whether it points in a particular direction or not. So here you can see that it is pointing in one particular direction. So we note down its orientation. Now if we gently give it a touch such that it starts to float once again and it is deflected from its original position now. So now let's carefully observe the orientation of the needle once again. So here you can see that the needle is now pointing in some different direction. Now what could be the reason behind this? Why is this needle not staying in a fixed position? Let me just give you a hint. So what does the magnetic compass consist of? Yes, so a magnetic compass, it consists of a magnetic needle which is pivoted inside a small box with a glass cover on it. So magnetic compass has a magnetic needle, right? But a sewing needle, it is not a magnet. So what should we do to magnetize it now? Okay, let me think. So if I rub this bar magnet over the length of the needle, then will this needle get magnetized? Okay, let us try it. And for this process, we place the needle on the table and then place any pole, let's say the north pole of a bar magnet, near the tip of this needle. Now, without lifting the bar magnet, we move it along the length of the needle. So I keep on moving it till I reach the other end. Now lift the bar magnet and bring the same pole with which we have started to the same point from where we had started moving along the length of the needle. And we again move it along the same direction, just like I'm moving it here. Now repeat this process for about 10 to 20 times, and thereafter we bring an awl pin near to this needle. So is this needle magnetized now? So students, here you can see that our magnetization process has worked. And now I'll place this magnetized needle over the cork and let this cork to float once again on the water surface. Now wait for it to come to rest and then we'll compare its direction with that of the magnetic compass needle. So what do you find here? Okay, you can see that it has stopped now. We note down its orientation and now I give it a gentle push. Now you can see that the needle is still pointing in the same direction as it was pointing earlier, and it is pointing in the same direction as that of a magnetic compass. And so our improvised magnetic compass is now ready. And now, if you want to magnetize an iron bar or an iron nail, then we follow the same procedure. So you have seen that when we rub the magnet against the sewing needle at least 4 or 5 times, then it begins to behave like a magnet, right? So you should know that magnets thus formed, they're normally weak and temporary. So probably you would be thinking that why has it happened? How does a normal sewing needle, it becomes magnetized? Well, a substance can be made magnetized by several ways. But here, we're talking about, or I'm going to provide you only one method, and detailed description of other methods you will be studying in your higher classes. Now just to answer this question, that how does a material, it becomes magnetized? So here we have a magnetic material such as a iron bar, and if we see its zoomed view, then you can see that the atoms in the form of tiny magnets in this iron bar, they're arranged in small units, and these units are called domains. So now each domain is like a box with a bar magnet inside. So normally inside this iron bar, all of its domains, they are arranged randomly, and these bar magnets, they point in some random directions. Thus, there's no result in magnetism, and that is why it behaves as an unmagnetized iron bar. But you know, when all the bar magnets inside the different domains, they point in the same direction, then we get an overall magnetic field, and we say that the iron bar is now magnetized. Now the question arises, how this is possible? how can we make the tiny bar magnets which are present there on the bar to align in the same direction? Or if I have to put it in simple words, how can we magnetize a normal iron bar? So the answer is, we can magnetize a normal iron bar by bringing a magnet near to it, or by moving it over the bar surface, like we did for the sewing needle, remember? So similar is the process for magnetizing an iron bar as well. So when iron bar, it is brought near a magnet, all the tiny magnets inside the iron bar, they tend to align themselves in one particular direction, in one single direction. And so in this way, an unmagnetized iron bar, it starts behaving like a temporary magnet. So students, in our next module, we will discuss that how a magnet, it gets demagnetized or how it becomes weak in magnetism.